Hello everyone. In this video, we are going to discuss about the topic naive Bayes. Naive Bayes algorithm. It's a supervised machine learning algorithm. We use it for the classification tasks such as text classification. It is based on the Bayes theorem with the naive assumption that all features are independent of each other. It calculates each class probability and it picks the one with the highest probability. Bayesian classification. It's a statistical classifier which performs probabilistic prediction, that is, it predicts class membership probabilities. It is based on Bayes' theorem. It's a simple Bayesian classifier, naive Bayesian classifier. It has a comparable performance with decision tree and selected neural network classifiers. Each training example can incrementally increase or decrease the probability that a hypothesis is correct. Prior knowledge can be combined with the observed data. Even when Bayesian methods are computationally intractable, they can provide a standard of optimal decision making. Let us see some of the basics of Bayes' theorem. The total probability theorem, probability of B is equal to summation of I ranges from 1 to m, probability of B given AI into the probability of AI. Bayes' theorem, probability of H given X equal to probability of X given H into probability of H divided by probability of X. Here, this X is representing the data sample. The class label is unknown, it's the evidence. And this H is representing the hypothesis that X, it belongs to some class C. And the classification is to find probability of H given X, that is the posteriori probability, the probability that the hypothesis holds given the observed data sample X. P of H, it is the prior probability, which is the initial probability. For example, X will buy a computer regardless of his age, income, and status. P of X is the probability that the sample data is observed. P of X given H, that is the likelihood. That is the probability of observing the sample X given that the hypothesis holds. For example, it's given that X will buy a computer, the probability that X is having an age in the range say 31 to 40 and has a medium income. Prediction based on Bayes' theorem. Given the training data X, posteriori probability of a hypothesis H, that is P of H given X, it follows the Bayes' theorem. P of X given H into P of H divided by P of X. That could be viewed as the posteriori probability equal to the likelihood into the prior probability divided by the evidence. That is, it predicts X belongs to the class Ci if the probability P of the class given X is the highest among all the values for all the K classes. The difficulty here is it is requiring some initial knowledge of many probabilities, which is involving some computational cost. Here, the classification is to derive the maximum posteriori, that is the maximal probability of Ci given X. We can derive this from the Bayes' theorem. As far as this theorem is concerned, here the probability of X will be constant for all the classes. So this is the part which needs to be maximized. So only this has to be maximized. So a simplified assumption is the attributes are conditionally independent. There is no dependence relation between the attributes. The probability of x given Ci could be represented in this way. Probability of x1 given Ci into the probability of x2 given Ci, and it goes on. So this is reducing the computational cost. It only counts the class distribution. Let us consider one problem using this naive-Bayes classifier. We have the training data set, which includes various attributes: age, income, student, the credit rating, and the class, whether Bayes computer equal to S or Bayes computer equal to no. There are only two classes, say C1 and C2. So C1 represents the Bayes computer as S and C2 represents the Bayes computer as no. Let us assume that we need to classify this data. There is a data which is coming in having the value age is less than or equal to 30 and the income is medium, the student category S, the credit rating is fair. We need to check, we need to classify this particular data. Given this particular training data set, and this is the data that we have to classify, let us see how we need to proceed. Probability of a class. From the table we can see this is the class label. There are only two different classes, say no S, buying a computer no, buying a computer S. For the first class, buying computer equal to S. There are 14 records here, out of which there are 9 records which tells the Bayes computer value as S. 1, 2, 3, 4, 5, 6, 7, 8 and 9. So 9 divided by 14 is 0.643. Then the probability of buying computer equal to no. There are 5 rows, say 1, 2, 3, 4 and 5. So 5 divided by 14 is the probability of buying a computer. So probability of the class is found. The next step is we need to compute the probability of x given Ci for each class, which means this is the data that we need to classify. We have to compute the probability of the age less than or equal to 30 for the classes C1, C2, and the probability of the income medium for the classes C1, C2, probability of the student S for the classes C1, C2, and credit rating fair for the classes C1, C2. Let us start with the age. Probability of age less than or equal to 30 given Bayes computer equal to S is 2 by 9, which means out of the 9 records, there are 2 records which has the ages less than or equal to 30. And probability of age less than or equal to 30 given Bayes computer equal to no. Out of the 5 records, there are 3 records whose age is less than or equal to 30. Then the next value is for the income medium. So the probability of income equal to medium given Bayes computer equal to S, 4 by 9. So 4 records are having the income as medium out of the 9 records. Probability of income medium given Bayes computer equal to no, there are only 2 records out of the 5 whose income is medium. For the class Bayes computer equal to no. Probability of student S given Bayes computer equal to S is 6 by 9. 6 records out of 9. Probability of student S given Bayes computer equal to no, 1. There is only 1 record out of the 5 records whose student is S. Credit rating equal to fair given Bayes computer equal to S is 6 by 9. Probability of credit rating fair given Bayes computer equal to no is 2 by 5. So for this data which is to be classified, the probability of x given the class Ci, we need to compute the probability for the two classes. So probability of x given Bayes computer equal to yes for the first classes, we need to find the product of all the probabilities. So this probability and this one and this one and this one. So the probability is 0.044. The probability of x given by its computer equal to no is, consider all the probabilities that belongs to the class label no. 0. 0.6, 0.4, 0.2, 0.2, 0.4. It's 0.019. Now we need to compute the product of probability of Ci and probability of x given Ci. When we are finding the product for the first class label Bayes computer equal to S, the probability is 0.028. Then for the second class Bayes computer equal to no, the probability is 0.007. Now we need to find which is having the maximum probability, which class has the maximum probability. We can see Bayes computer equal to S has the maximum probability 0.028. So we can conclude this data belongs to the class Bayes computer equal to yes. Advantages of naive Bayes classifier: it is easy to implement, it works well with small data sets, it performs well in text classification task, it gives good results. Some of the disadvantages includes it struggles with highly correlated features. Normally, dependencies exist among variables. So these dependencies cannot be modeled by the naive Bayes classifier. Thank you.